So you want to take the Security Plus. You get to this section where you need to know all these Linux commands, right? Not just Linux, you need to know Windows commands too. You don't want to sit there and memorize definitions of commands. No, what you need to do is actually use these commands and get some hands-on experience that will help you remember what these commands do. So today in this video, I'm going to walk through the commands that we will need to know for the CompTIA Security Plus exam. And if you are at your computer, I highly recommend that you follow along and do this yourself, because you might want to take a little more time on some and you might want to skip over some of the others. Let's get into it. So over here, I've pulled up the CompTIA Security Plus learning objectives. You can see here the list of tools and commands that they want us to learn. I'm not going to go through all of these tools today, but I'm going to cover most of these commands. And you can see the first one here, example, is tracert or traceroute. And the reason they have it listed with a slash is because they're basically the same tool. One is for Linux and Mac, one is for Windows. So what I've done is I've pulled up Kali Linux in Oracle VirtualBox. And by the way, if you haven't done this before, I did a live stream where I walk you through real quick, like in 10 minutes, how to do this for free and get your own version of Kali Linux up and running. And then I just have my command line through my host operating system. So with the first command on the list being tracert, what does this do? This basically helps us pinpoint areas in our network that may be breaking down. It helps us narrow down where the problem may be. And the way it does that is it uses a time to live value that is assigned to ICMP packets. And it sends these ICMP packets out and sets the time to live at first to 0, then to 1, then to 2, then to 3. So it's getting information from every single device along the way, and that's why it's called traceroute, because it's tracing the route from your endpoint to whatever IP address you specify. All right, so let's go ahead and try traceroute on Kali Linux, and I'm going to do this to facebook.com just so we can get an idea. You can see the first IP address listed here is on my internal network. That's an internal IP address, and then you can see it's going to a Spectrum address. So obviously, it's going into Spectrum's internal routers, bouncing through 3 of those charter routers and switches, and then a whole bunch actually. So I don't necessarily know what all of these are, but I know that my router is connected directly to Spectrum, and from Spectrum, it's going to a bunch of charter machines. It's popping through all of those, and so basically, each one of these is a ping that has a slightly longer time to live, right? And that's how traceroute figures out where each point is. Now, if you were troubleshooting an internal network, you would see a problem along the way. And let's say, it was this device here, number 5, then you would know that something's wrong with the device at this IP address, and we could go troubleshoot that. So I've used traceroute actually a lot in my job, and troubleshooting internal networks at an enterprise and trying to figure out, is it the switch, is it the endpoint, is it the router, is it the site-to-site VPN, and it shows you where that connection is breaking down. All right, so now we're going to try the same command on Windows command line, and we're just going to do a traceroute to google.com. So you can see here it's actually quite a bit slower. It's doing a default setting of, I believe, 3 pings to each point along the route, and it's giving us the latency, so that's cool. Again, you can see it's going to my home router, and then it's jumping into Spectrum, and then going to charter devices. We'll expect to see 3 to 5 charter devices here, and we're getting the different IP addresses for each of these devices along the way. This is a useful tool, and it definitely has its place for a help desk or a network technician. If a user can't reach out to a certain site, you might do traceroute to that site, which you can enter IP address or the domain name of that site, and you'll trace your path there. So we can see we're not getting as much information here. This could be maybe Google's network devices or something like that. And then it does give us in the end this name here and this IP address for a server that is serving the google.com website. tracerout's pretty cool, but what if you don't know the IP address of a device, or what if you don't know the domain name of a device, but you have the IP address? Well, that's where nslookup comes in. So nslookup or dig is used to gather information on a domain name. So we're looking up google.com, let's say, and it should give us an IP address that will resolve to google.com. So you can see here the answer for DNS is being given by the IP address that is attributed to my home router, and that's because my home router, it knows where google.com is, and so it sees this device asking, hey, does anyone know where google.com is? And my home router is actually answering and saying, yeah, I know where google.com is. It's at 142.250.176.14. So this is why it says non-authoritative answer. Now, if my home router did not know where google.com was, this request would go to, a higher level to look for the answer to this nslookup. And I believe if it got to a high enough level, it would come back as an authoritative answer. All right, so nslookup is great, and I've also used this in the workplace, actually. For example, I had the workstation name of an employee, but I needed to issue a command to that workstation based on the IP address. So I would just do nslookup and then type in the workstation name, because really this is giving me this is giving me information about domains, but it also gives me information about hosts on domains, right? So if you have a bunch of hosts in a domain on an enterprise level, you can find the IP address with the workstation name, or you can find the workstation name based on the IP address. It's useful, but it's a little outdated. And it works the exact same way on Windows, so I'm not even going to switch over to that one for this. But a more advanced tool, which I actually don't have very much experience with, but I want to show you guys nonetheless, it's called dig, and let's see what dig gives us when we look up a dig on google.com. You can see here there's a lot more information. It's a little overwhelming, to be honest. But we get a header. No error, ID, flags, blah, 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 google.com. So comparing nslookup to dig, see, an nslookup, it basically just gives us an IP address and an IPv6 address. When we go down here to dig, we get the same IP address here. It doesn't look like we get the IPv6 address by default, but we do get a lot more information. And, I'm using the very basic levels of these commands. The idea is just to get a little bit of experience, get a little bit of familiarity, get something in your head that will help you to remember this for the test. You don't have to understand every single flag, every single option. You just need to know maybe what these would be used for, right? All right, next on our list is ipconfig and ifconfig. So ifconfig is, I would say, probably the most used and most basic networking command that you should definitely know. The Windows version is ipconfig. So ifconfig, I believe, stands for interface configuration. So this right here shows you I have two interfaces on this virtual machine. One is facing my home network, and another one is the self-assigned or loopback address. And so this is pretty standard. If you have a computer with one connection, you will see the internet, and then let's see the internet. So the interface name is here, Ethernet 0, and then we have the iNet address, which is my IPv4. We have iNet 6 assigned here, and there's a lot of other statistics and information, how many packets have been sent, how many packets have been received, and you can see here the loopback address as well. So this is great if you're on a workstation and you just want to see, like, is DHCP working for this workstation? Has it received a valid IP address? Real quick, you just type in ifconfig and you will get the IP address of the workstation. And if it shows only the loopback address, then or if it shows like an APIPA address, then you know that it's not communicating with DHCP properly. ipconfig, and boom, we get a whole bunch of information because I have a lot of interfaces configured on here. So let's see, we have Ethernet adapter, virtual Ethernet, Ethernet adapter 2, Oracle VirtualBox Ethernet, a VM switch, and there's There's a whole bunch here, but basically you get the similar information. It gives you subnet mask, IPv4, IPv6, and yeah, you know, knowing which one of these you're actually looking for and which ones they are is a matter of knowing a little bit more about your network and you know, public versus private IP addresses. So me knowing my network is 10.0.0 WAC24 or yeah, 10.0.0.0 WAC24, I know that this is the address that's actually going to go out to the internet and back, right? All right, so we know how to find IP addresses, domain names. We know how to test connections from point A to point B. We know how to get the IP address of a device from that device. But let's say we want to scan a device remotely and figure out what ports are open on that device. Now, this is where nmap comes in. Nmap is probably one of the most popular tools, I would say, in Linux. At least if you're focused on cybersecurity, if you're focused on like penetration testing, this is like one of the very first things that you will learn. So nmap, there's a whole bunch we could say about nmap. So if you wanted to scan, let's say, the top 1,000 ports, that'll happen by default. And it's not the top 1,000 as in 1 to 1,000. It's the top 1,000 most used ports. And let's say you wanted to see what versions of services were running on those ports. So you would do a lowercase s and capital V. Keep in mind, in Linux, capitalization matters. Every command is case sensitive. So nmap-sv, and then you would enter the IP address of whatever it is that you wanted to scan. All right, so I'm kind of doxing myself here, but I scan this IP address knowing that that's the address assigned to my printer at home. And you can see I scan for service versions. So you can see we have port 80 open, which if you know your port numbers, you already know that's HTTP. But this actually will give us the name of the service, and it will give us the version of the service. So we get a lot of information here. Port 80 is open, 443, 515, 631, 9100. And we have all of these service names here. And, you know, I just recommend doing an nmap lab, messing around with it, scanning devices on your own network. Do not scan devices that you do not have permission to scan, because that is illegal, I think. It's not a good idea. Don't scan devices you don't have permission to scan. So I recommend getting your hands-on experience with these commands, but I also would suggest getting some cheat sheets. So like I just Googled nmap cheat sheet, and you get these useful cheat sheets which gives you information. You want to scan a single IP. You want to scan a specific IP. You want to scan a range. This gives you the syntax for range. And then these are ones I would definitely recommend knowing as well. Different types of scans you can do. So there's a SYN scan where you only send the first step of the three-way handshake. Three-way handshake is SYN, response, SYN ACK, response ACK, right? If you don't know what that is, just look into it. But the SYN scan only sends the SYN. The ST is a TCP connect port scan. You can do a UDP scan. You can do an ACK port scan. There's so many different things you can do with nmap. All right, let's say we don't want to scan ports at all. Let's say we just want to see what's on the network. Now, this could be done with a third-party program like Advanced IP Scanner or Angry IP Scanner or any of the other billions of IP scanners that are out there. But if we already have a command line open and we know how to use nmap, then we can do it with nmap. So let's say we do nmap and we do a host discovery only. It's lowercase sn, okay? And we just want to know what's in the range of 1080 through 90. So we do that, and now we're only doing host discovery. It's very quick, and we don't need to wait for all the ports to be scanned. And let's see what we get here. Nmap done. One host is up. Nmap scan report for 10.0.0.90. You could also enter an insider notation. You could scan the entire network, 10.0.0.0 WAC24. And there you have it, all the answers of, you know, which devices have, which IP addresses are being actively used by different devices. Now, there's other flags you can add on here to get more information, or you could just use a third-party program like Advanced IP Scanner or Angry IP Scanner, any of the other billions of IP scanners that are out there that have automated this process, and it'll also be in a nice GUI. But we're not here to use nice GUIs. We're here to get hands-on experience, right? So Next on our list is ping, and I may have lied when I said ipconfig was the most used tool because I think ping might be the most used tool. Ping is simply, do I have connectivity to a device? And it'll ping and ping and ping. In Linux, it pings forever. If you want to stop, hit Control-C. In Windows, by default, it will send, I think, 4. Let's see. So, can I reach my home router? That is the question. And the answer is yes, you can. The latency is less than 1 millisecond. We sent 32 bytes. The time to live was default set to 64, and we reached it in under 1 millisecond every time. The loss was 0%. In Windows, if you wanted to send a continuous ping to monitor connectivity for a device, you could use the T flag, and that would just keep going like it does by default in Linux. Let's say you could leave this on for 24 hours and, to monitor connectivity between two devices over a certain period of time. You come back the next day, you hit Control-C, and it will give you the percentage of loss of packets over a 24-hour period. So that's kind of a cool way to monitor connectivity between two devices over time using a very simple tool like ping. All right, I'm going to skip over a couple of these due to time constraints, and we're going to jump into file manipulation on Linux. Now, I am by no means a Linux pro. If you haven't noticed, I have limited experience with Linux, but I've enjoyed learning about it, and if you're new to it too, then hopefully this will be helpful to you. So, first things first, I'm going to simply make a file called file.txt. And that's just so we can mess around with that and manipulate it. So let's say you have a file and you know it's a massive file and you don't want to look at the whole thing, but you just want to see like what's in there and get a peek, right? So that's what head is for. So if you type in head and we look at head file.txt, you can see the first 10 lines of what I have put into that file. So that's pretty useful, right? Now the converse of that would be tail. Tail lets you look at the last 10 lines. So maybe, let's say there's constant information being streamed into a file and it's being added at the bottom, and you want to see what was the most recent thing that was added, or maybe you just want to see what's the end of the file. So you use file tail file.txt, so tail and then file name, and then boom, there you go. You get the 10 last lines of the file. That's pretty simple. It's just giving you basic information, right? Now, if you do want to see the whole file, you can use the command cat. So we use cat, we put the name of the file, file.txt, boom, that's the whole file right there. So it's a bunch of random stuff that I typed because I was trying to make an example so we could learn things. All right, now what if you have a really big file and you're just looking for specific information? That is where grep would come in. So grep can help you search files for certain strings. So let's say we want to use, we're wondering where was the number 4 typed in this file. Like I'm looking for the number 4. So we grep, and we put the thing that we're looking for, and then we put the name of the file. And boom, it gives us the lines, the full line of anywhere the number 4 was typed. So similarly, we could look for the word subscribe. And please subscribe now, eh? Now for the doozy. If all these other commands have been easy for you and you're like, this is no problem, I got this, Linux is easy, this one might trip you up. So pay very close attention. I call this command chmod. I don't know how it's actually pronounced, but I call it chmod. Okay, I just looked it up and it is actually pronounced chmod. And it stands for change mode, which is modes of accessibility, modes of authorization. So basically this is used to change permissions on files, on directories, and it is not as complicated as you think. First things first, let's use the ls command, okay, which is what we use to look at things. And let's see what's in here. Okay, we're in my home folder, right? So we have desktop, documents, downloads, file.txt, music, pictures, public, templates, and videos. Okay, well, what if we want to see the ownership qualities of these files? We can use ls-l, which is for long mode. And look at that. We can see D indicates that these are directories. And so the only one that's not a directory is this file.txt that I've created. R stands for read, W is write, X is execute, and then it starts over. If there's a dash, it means, so we have three, so this is showing permissions for three different groups, okay? The first one is user, the second one is group, and the third one is others. User means owner of the file. So the owner of desktop can read desktop, they can write to desktop, and they can execute desktop. Others, meaning users outside of the owner, can read desktop and they can execute desktop, but they cannot write to desktop. The second one is for group, and this means that group can read and execute, but they cannot write. That is why you see a dash there. And then for others, meaning everyone else that's not included in the user category or the group category is considered others, and the others can also read and execute desktop, but they cannot write. Okay, so for this file.txt that I have created, it is not a directory. Me being the user or the owner of the file, I can read and write to it. I cannot execute it because I suppose that's default security permissions. The group, meaning members of the group the file belongs to, can only read it, and everyone else can only read it. So this gives us a good idea of what permissions look like in Linux, how to read permissions. Just remember the ls-l command. So let's check and see if we can change the permissions here. Now, one way to change the permissions is to use the letter indicating one of those three groups that I explained, and then plus or minus certain permissions. So let's say we wanted to give ourselves, the user or owner of file.txt, execute permissions over that file. We would do chmod u plus x, not chmod, chmod u plus x file.txt. All right. And now if we list those same permissions, we can see we have read, write, and execute permissions, whereas before we only had read and write. Now it works the same way. If you wanted to remove those permissions, you could do u minus x on file.txt. And once again, we see the execute has been removed, and we now have read and write capabilities. So that is a granular way to remove and add. Now, if you wanted to change the permissions for group, you would use G, and let's go ahead and give them write and execute permissions on file.txt. And we can see we've added read, write, or we've added write and execute for group, and others would be O instead of G. So this is one way to alter the permissions on a file. In like pen testing labs, a lot of times when you create something or when you download a file or something, you just need to add chmod plus x. You don't even need to specify. If you don't specify who it's for, then it's for everyone, okay? So you'll see here, boom, we just gave execute permissions to everyone, and maybe we don't care, maybe that's fine, it's faster, whatever, it's done. All right, so that is one way to change. Now, the other way to change modes for a file is based off of numerical shorthand. Now, this is where it gets a little more complicated, okay? So I want you to think of these three values, R, W, and X, as being in binary. Now, if these are in binary, the X would be 1, the W would be 2, and the R would be 4. So what this means is we can represent a combination of R, W, and X, all combinations, with 7 numbers. Sorry, with 8 numbers, being 0 through 7. All right, so this looks super weird, but basically 0 would mean no permission. 1 would mean execute only, because we're giving it a bit in the third slot there. Write permissions would be a 1 in the second slot, which would translate to 2 in binary. Read and write would be 3. Read only would be 4. 5 would be a combination of read and execute. 6 would be read and write. And 7 would be all of the above. So you can see how this translates into shorthand because we're using binary, right? So let's just clear the screen. That's Control L. And now let's chmod. Let's give 0 for myself and full permissions to the other guys. Okay, and we're going to do that to file.txt. And if we list it, you can see the user or owner of the file has 0 permissions, and groups and the group and others have full permissions. So that's pretty cool. Instead of having to, type. In any case, that's the shorthand. I'm going to give myself back full permissions, and I'm going to give read and write would be 6. So let's give 6 to the other 2 groups, and this will basically restore. Actually, we had it as 6. Yeah, this was the original. This was the original setup of the file. So now we can see we're back to read and write. Oh no, that wasn't it. Well, anyway, that's how chmod works. That is chmod. Chmod is great. There's one more command I want to show you guys real quick. It's pretty cool. This command is called curl. Curl is extremely diverse and extremely useful, and the best way I can explain it with my small brain is that it's for grabbing things from places. It's like get. It's like getting things from places, and it's so diverse. It can be used with so many different protocols, and I just want to show you guys from the manual. It supports these protocols: dict, file, FTP, FTPS, gopher, gophers, HTTP, HTTPS, IMAP, IMAPs, LDAP, LDAPs. All of these different protocols which are used for transferring files. Okay, so it's like your super multi-tool for grabbing stuff off the internet. And I want to show you guys an example of this. So I grabbed a URL for a picture, and if we want to dictate the output of what curl is going to grab, we can use the -o flag, and then we can give it a name. And it's just going to save it to the local file here, and then the URL here is this random website. And so if we use that, boom, look at that. Okay, we just grabbed something from the internet. We output it as gr.png, and this was the web address that we went to. It was 140 kilobytes download, 0 upload, speed was fast. Great, awesome. So let's check it out. What did we download? We're in the home folder, and look at that. We downloaded gr.png. Isn't he cute? That is all I have for you guys today on this brief overview of some of the commands that you will need to know for the CompTIA Security Plus. I hope it was helpful for you. If you did enjoy it, please subscribe, hit the like button. And if you'd like me to go in more depth on some of these other tools that are going to be on the Security Plus, let me know in the comments down below, and I'll be happy to make that video for you guys. Bye.